Hi, we are Smart Bike team. We are working on self-balancing bicycle with perception. We have 3 team members, which is Wenhao, Abhinav, and Azil, and this is what we are working on.
This is the basic idea of the project. We have been working on 2 modules. One is the ROS module and the other is the image processing module. For the image processing module, we have worked on traffic signs and lane detection. And for the ROS module, we have worked on point cloud data feature extraction and enhanced obstacle detection.
So the first step of this project is achieving self-balancing of the bicycle by steering control, and this video showing the initial test of the PID control. So after tuning the PID controller, we are able to achieve self-balancing at different forward speeds.
Okay, now let's move on to the actual perception part of the project. The first module we worked on is the image processing part using the Raspberry Pi camera to detect the bike lanes for the bike to navigate safely. In this, we selected a region of interest by specifying the width and height parameters in the frame to be processed and used how transforms to actually detect the boundaries by specifying the low height and high height parameters. Now, the video demonstrates how the bike would actually follow these guidelines in a well-defined boundary. This is another important aspect in our image processing module. We are now able to detect basic turn signs by reading the sign on a warped image with 4 rectangles. Based on the area coverage on the region of interest, we were now able to detect the signs and give guidance to the bike when it's running autonomously. Color detection is important in any autonomous driving vehicle, especially in detecting the traffic signals. We now demonstrate the basic idea to detect the colors in real time of different objects. The basic idea behind this is to specify the lows and highs of each color in RGB format and then process the image in real time.
This is the second module that we worked on using ROS for our LiDAR. We use scan sweep ROS LiDAR package to visualize the 2D point cloud data in real time, and we were able to extract this detail using a web-based platform. We were also able to display this LiDAR's information using polar coordinates. The other part of the ROS module we worked on is detecting obstacles. This is a flowchart of a ROS module. In this, we have various nodes to scan the point cloud, then a scan merger to merge the data and extract the obstacle points and also track it. We identify the obstacles that are circular and straight lines here. We do it by identifying the point cloud shape and merging things that are closer than the given threshold. By this way, we can identify the extent of the obstacles. Once this part is done, we detect obstacles. Here, we only track the circular obstacles. This kind of tracking will be helpful to predict the motion of the obstacles in future, by which we can prevent hitting the obstacles. This video demonstrates how the point cloud actually visualizes in real time as it encounters obstacles.
That's it, folks. This project wouldn't have been possible without the help from the RISE Lab Smart Bike team members under the guidance of Dr. Zhang. And we would also like to thank the course TA and the instructor, as well as Mr. Tysick, for providing us the ROS LiDAR package.